Now let's see what inverse, sine, cosine, and tangent functions are. So basically, I think you've seen this before. The sine inverse function is defined like this. If y is equal to sine inverse of x, then x is equal to sine of y, right? Basically, if this sine is taken to the left-hand side or any opposite side of the equation sign, it becomes the sine inverse function, right? But there's a limitation to this. See, x can only have a value of -1 and 1 and anything in between, right? So it lies between -1 and 1, as you can see in the graph of a sine function. This is 1 and this is -1. The value will always lie between these two values. So when you plug in these values of x and then sine inverse that value, it will always lie between -π/2 and π/2. Okay? Now, similarly, for an inverse cosine function, you have the same equations except in terms of the cosine, and x again will always lie between -1 and 1, as the graph is same but the phase is different for a cosine function, right? It's something like this, right? But again, it's between 1 and again -1. So if you plug in those values of x that are between 1 and -1, the value of y that we'll get from the inverse cosine of x will always lie between 0 and pi. Okay, so the inverse tangent function, again, the value of x will lie between -infinity and positive infinity, right? As you can see, the graph of tangent is something like this, right? But again, if you make a line over here, the value of x will keep on going till infinity and again till -infinity. So which is why the value of x can have any value. But if you plug in any value of x over here and take the tangent inverse, the value of y that results will always be between -π/2 and π/2. Now again, you apply the same logic for the cotangent, secant, and cosecant functions, right? Again, the x value of a cotangent function can be any value between positive infinity and -infinity. But again, if you plug in those values over here and take the inverse cotangent, you'll get a value between 0 and pi. And again, for the secant function, the value of x will always be greater than 1, right? So if you take any value of x, the modulus of x, the absolute value of x will always be greater than 1. So right, so x cannot have a value between -1 and 1, right? So again, it will always be greater than 1 and less than -1, which is why when you plug in those values, you'll get a value of y. If you plug in those values over here and take the secant inverse, you'll have a value between 0 and pi, except that you'll not have a value of y that is equal to pi/2, because I think those values lie in this region, right? Okay, so again, the inverse cosecant function is like this, and again, it's the same for x. The absolute value of x must be greater than 1, so it will always be less than -1 and always be greater than 1, nothing in between. So when you plug in those values over here and take the inverse cosecant function of those values, you'll get a value of y that is between -π/2 and pi/2, but not including 0. Okay, so yeah,